Welcome back, everybody, to another deep dive. This time we're going to be looking at large language models, LLMs.
LLMs.
Yeah, those AI systems that you hear about everywhere these days.
Yeah.
And to guide us through this deep dive, we have a fantastic recent article from Towards Data Science.
Oh, yeah.
It explains LLMs in a really clear and engaging way. It even compares itself to that really long YouTube video on LLMs.
Yeah, that's a long one.
It is. It's like 3.5 hours long or something.
Yeah, but no worries. We're going to distill all the good stuff from that video in this article right here for you without the overload.
Awesome. So LLMs, they can write poems,
Yeah.
they can translate languages, they can even code.
They can even code.
How is that even possible?
So at their core, LLMs are based on predicting the next word in a sequence. But to get there, there are two key phases:
Okay.
pre-training and post-training.
Pre-training and post-training.
Yes.
Could you elaborate on those a little bit?
Absolutely. So pre-training is all about building a foundational understanding of language. It's like teaching a model the rules of grammar syntax and even some semantic relationships between words. And the fascinating thing is that we're not programming these rules into the system.
Right.
The LLM actually learns them by itself.
It learns the rules itself. How does that work?
It all starts with data, massive amounts of data. We're talking about feeding the LLM a digital feast of information,
Okay.
often using data sets like Common Crawl, which has a mind-boggling collection of 250 billion web pages.
250 billion web pages. So like the whole internet, basically.
Pretty much.
Yeah.
And of course, not everything on the internet is accurate or valuable, so cleaning and filtering this data is a crucial first step in the pre-training process.
Right. That makes sense.
Hmm.
So once that data is cleaned up, how does the LLM actually process and learn from it?
This is where things get really interesting. So the text is first broken down into smaller units called tokens.
Tokens.
Yeah, it's like a code where each token represents a word or part of a word, or even punctuation marks.
Okay. Why not just use whole words?
That's a great question. Tokenization is important because it helps LLMs handle the messiness of real-world language. You know, like new words, slang typos,
Yeah.
all things that LLMs need to be able to understand.
So it helps it adapt to how language is always changing.
Exactly. Once the text is tokenized, it's fed into a neural network. Think of it as a vast, interconnected network of nodes, kind of like a digital brain.
So it's kind of like our brains then, with the neurons firing and making connections and stuff?
It's a simplification, but the analogy works. So during pre-training, the neural network is constantly trying to predict the next token in a sequence based on the tokens that came before it. It's like a giant game of guess the next word, but on an unimaginable scale.
And I'm guessing it gets pretty good at that after looking at billions of words.
It does. And every time it makes a prediction, it receives feedback on whether it was right or wrong. And through a process called backpropagation, the LLM adjusts the strength of the connections between those nodes, constantly refining its ability to predict the next token with really incredible accuracy.
Wow. So that's pre-training. What happens in the post-training phase?
Post-training is where we take that foundational knowledge and refine it for specific tasks. The pre-trained model at this point is like a rough draft.
Okay.
It can predict text like a champ, but it doesn't necessarily understand how to follow instructions or perform specific tasks reliably.
So it's like having all the ingredients but not knowing how to make a specific dish.
Exactly. Post-training involves fine-tuning the model using specialized data sets designed to teach it specific skills. For example, we might use instruction fine-tuning to teach the model to follow commands and be more task-oriented.
So we're kind of teaching it how to use all that knowledge practically.
Exactly, like teaching a student who's aced their vocab test how to actually write an essay. We're shaping that raw potential of the LLM into something with real-world applications. And this fine-tuning can be applied to a wide range of tasks, from writing different kinds of creative content to translating languages, even coding.
That's incredible. So we can tailor these LLMs for different purposes by fine-tuning them with the right data.
Exactly.
That's incredible. So
Yeah.
we can tailor these LLMs for different purposes by fine-tuning them with the right data. It's
Exactly.
really amazing the level of customization we can achieve with these LLMs. But
Yeah.
let's shift gears for a second and talk about how these models actually generate text.
Okay.
So we've covered pre-training, we covered post-training, but what happens when we want the LLM to, say, write a song or translate a document?
That process is called inference.
Yeah.
It's essentially how the LM uses all that learned knowledge
Right.
to generate new text based on a prompt.
So if I ask an LLM to write a haiku about the ocean,
Yeah,
it uses everything it's learned about language and poetry and oceans to create something new.
precisely. And the fascinating thing is it's not just pulling pre-written phrases from its memory. There's a crucial element of probability involved in how it selects each word.
Probability.
Yeah.
How does that play into text generation?
So for each word it generates, the LLM considers a range of possibilities,
Okay.
each with its own probability score. Based on the preceding words and its training data, it's kind of like a weighted coin flip,
Uh-huh.
where some words are much more likely to be chosen than others.
So it's not just picking the most statistically likely word every time.
Right, because that would probably make for some pretty dull and predictable text.
Yeah.
This probabilistic approach allows LLMs to be much more creative and generate a wider range of outputs even for the same prompt.
Mm.
It introduces an element of randomness that makes the generated text feel more dynamic and, dare I say, human-like.
That makes a lot of sense. But if LLMs are essentially making educated guesses, is there a risk that they'll sometimes guess wrong? Like, could they generate text that's just plain incorrect?
That's a really important point, and it brings us to one of the biggest challenges in the field of LLMs,
Yeah.
hallucinations.
It's hallucinations.
Yeah.
So like the LLM is seeing things that aren't really there.
Not that they're actually seeing things, but they can generate text that sounds plausible,
Right.
but is factually inaccurate. You have to remember, LLMs don't truly know things the way humans do.
Okay.
They're incredibly good at predicting patterns in language, but they don't have a deep understanding of the real world or the meaning behind those patterns.
So like they could write a convincing biography of a fictional character,
That's a great example.
pulling details from different sources, but ultimately creating a story that's totally made up.
Exactly. And while these hallucinations can sometimes be amusing, they can also be a serious problem, especially if we're relying on LLMs for tasks where accuracy is critical.
Right. So how do we address this issue of hallucinations? Can we teach LLMs to be more truthful?
There's a lot of ongoing research focused on improving the factual accuracy of LLMs. One approach is to train them to recognize the limits of their knowledge
Okay.
and to say, I don't know.
Right.
When they're uncertain about an answer, it's kind of like teaching a child to admit when they don't know something instead of just making something up.
That seems like a sensible approach. Are there other strategies for reducing hallucinations?
Another promising avenue is integrating LLMs with external search tools.
Okay.
This allows them to access real-time information from the web, which can supplement their internal knowledge base and make them less likely to hallucinate.
Right. So it's kind of like giving the LLM a research assistant
Exactly.
that can double-check its claims.
Yeah.
That's a pretty clever solution.
Yeah.
So we've talked about how LLMs learn from massive amounts of data.
Yeah.
But how do they actually access and utilize that knowledge when they're generating text? Like we've built this enormous library of information.
Okay.
How does the LLM find the right book at the right time?
That's a great analogy. And it brings us to the concept of an LLM's memory, which can be thought of as having two distinct types:
Okay.
vague recollections and working memory.
Vague recollections.
Yes, these represent the vast knowledge stored in the model's parameters from pre-training.
Right.
It's all there, but not easily accessible or searchable. It's more like those distant memories we have.
Yeah.
We know we learned something about, say, the Roman Empire in school,
Yeah.
but we might not be able to recall the specifics without some prompting.
So it's like knowing that you have a book on a particular topic somewhere on your bookshelf, but not being able to put your finger on it right away.
Exactly. And then we have working memory, which is much more immediate and focused.
Okay.
This is the information that's directly available to the LLM during inference,
Right.
the information it's actively using to generate text.
So if I ask an LLM to summarize a news article, the article itself becomes part of its working memory.
That's a great example. And the size of this working memory, often called the context window, can vary significantly depending on the specific LLM. Some models can hold thousands of words in their working memory,
Wow.
enabling them to process and understand complex pieces of text.
It makes me wonder about the limits of these systems.
Mm-hmm.
With all this knowledge and the ability to generate human-like text,
Yeah.
do LLMs ever develop any kind of self-awareness?
Hmm.
Do they know that they're an AI?
That's a question that sparks a lot of debate and philosophical discussion.
Right.
It's important to remember that while LLMs are incredibly complex,
Yeah.
they're still machines.
Sure.
Their responses to questions about their identity are based purely on patterns they've learned from their training data, not on any genuine self-awareness.
So when an LLM says something like, I am a large language model, it's not because it has a conscious understanding of its own existence.
Exactly. It's simply reflecting the patterns it's encountered countless times in the text it was trained on. We can, however, use techniques like system prompts, To give the LLM a consistent persona and set boundaries for how it should describe itself. It's a way of shaping its identity for specific applications.
That's a fascinating insight. It sounds like we're still in the early stages of understanding the full potential of LLMs.
Absolutely. The field is evolving incredibly rapidly, and we're constantly learning more about what these systems are capable of.
Yeah, it really is incredible to think how far this technology has come in such a short time.
And we're really only just scratching the surface of what's possible. The research and development in this field are moving so fast.
Well, listeners, we've covered a lot of ground in this deep dive. We explored the intricacies of pre-training and post-training,
Yeah.
delved into the probabilistic nature of inference, and even grappled with the challenge of hallucinations.
Yeah, it's a tough one.
We also examined the fascinating concept of an LLM's memory, with its vague recollections and more focused working memory.
Right.
And we even pondered the intriguing question of whether these systems possess any form of self-awareness.
Such a fascinating question.
And you know what? All this was based on just the first part of a two-part series from Tortoise Data Science.
Really?
Yeah, there's a whole other article out there that goes even deeper
Wow.
into the world of LLMs.
So what does it cover?
Well, that second article explores some really cutting-edge stuff like reinforcement learning with human feedback.
Oh, wow.
It also examines some groundbreaking LLM architectures that are really pushing the boundaries of what we thought was possible.
It's pretty mind-blowing to think about.
It really is. It makes you wonder what the future holds for these incredibly powerful AI systems.
It does. It really does. As LLMs continue to evolve and become more sophisticated, they're going to have a profound impact on our world.
Yeah, for sure. So as we wrap up this deep dive, I want to leave you with a thought to ponder. If LLMs can already do so much, write different kinds of creative content, translate languages, even generate computer code,
It's amazing.
what will they be capable of in 5, 10, or 20 years? What new possibilities will emerge?
It's an exciting time to be following this field, that's for sure. And with all this progress comes a responsibility to ensure that these powerful technologies are developed and used ethically and for the benefit of all humankind.
Absolutely. Those are definitely some important things to consider. Well, that's all the time we have for today's deep dive. Thanks for joining us on this incredible journey into the world of LLMs. We hope you found it insightful and thought-provoking.
Until next time, keep those minds curious and keep exploring.
See you on the next deep dive.